All right, we're here performing a wet test on a Spectra Cape Horn Extreme. We're just here at my boat where I've got 12 volts and San Francisco Bay. So there is no system serial number since I built it myself, but there is a Clark pump serial number, which is 12778-10, with the 10 standing for a 10% Clark pump. Give a bit of an overview of the system. So this is the high pressure module, which consists of the Clark pump and the pressure vessel with a 40-inch membrane inside, all on an aluminum skid. This is essentially the same high pressure module on most of the Spectra line, the Catalina series, the Catalina 340Z, the Newport 400. The only difference is in how we feed it. It's feed water. Those systems all use a vane pump on an electric motor, which is great, but a vane pump will be destroyed in just a few minutes if it runs dry. So you have to have circuitry, a computerized system that'll shut down the system in case it runs dry. On the Cape Horn Extreme, we use two of these SureFlow pumps, which are souped up versions of what you might use on a pressure water system or something. So with them, you don't need any circuitry. They have simple on-off switches. They're indestructible. You can run them dry indefinitely, and they just aren't damaged. And they're also fairly cheap. You can replace an entire pump for about $350, or the pump head for about $250, whereas a vane pump head is over $700, I believe. The electric motors on these pumps essentially go forever. You can replace the brushes. The pump heads go a few thousand hours, and you'll start seeing diminishing feed water pressure, and then it's time to replace them. So let's go through how I've got this set up. I'm drawing water from the bay right here through the C strainer, which is the first line of defense in filtration. Then we go over to feed pump module A, where our main input is. And this can be a little hard to see in the manual, but pump A right here is getting its input right back in here. Pump B, there's a T here, and pump B gets its input right there. On the output side, pump module B, it's a straight shot inside the box from the pump right up to the bottom of this T on the high pressure filter housing, which has a 5 micron filter inside. On module A, we're coming off the outside of the pump and to the other side of the T. The only part that's confusing about this is on module A, it's getting its input from inside the box, its output is on the outside of the box. Module B is the opposite. It's getting its feed on the outside of the pump, and then, as we saw, the straight shot up to the T. So on the other side of the high pressure filter housing, we've aggregated the outputs of both pumps. Our next stop is an accumulator tank. This is just to take the pressure spikes out of the system from the Clark pump. You can see how it twitches every time the Clark pump changes direction. If you have enough hose, it'll do the same thing, but they use the accumulator tank on all systems. It's also a convenient place to connect our feed pressure gauge. And then the final stop is the feed water inlet into the Clark pump. Then the brine discharge, I'm just using the brine discharge service hose and sending all the brine back on in. I already did a total flow test, and everything's performing exactly within spec per Spectra guidelines. So let's do a water sample and look at the gauges. Strangely, we're performing a bit above spec. It's putting out about 16 gallons an hour. It's only supposed to put out 15. And our pressure is just over 75, and it's supposed to be 90. So I can only assume that the water here in San Francisco Bay isn't quite as saline as the open ocean. we do have two big rivers that come in. So let's take a water sample here. And that's enough. So these handheld gauges aren't ever terribly accurate, but they give a good idea. So here's a Hanna handheld meter, and it's saying 155, 158. It's stabilized at 160. So anything below 300 is considered excellent. And then here's a different Hanna handheld meter, and it's saying about 120. So definitely making good water there. Also, the voltage is a bit low. Spectra wants at least 12.5 going into this, and my batteries are at 12.1. So low voltage, and it's still putting above output. So once again, I think this water is probably not as saline as the open ocean. So the beauty about this system is the two pumps giving you full redundancy. You can have a full feed pump failure and still be making 9 or 10 gallons an hour. Also, if you've got very saline water or very cold water, that'll drive your feed pressures up too high. So you can run on one pump and get the feed pressures and still be operational. So let's do that right now. Let's turn off feed pump module B. We're just running off of A now. And we see our feed pressure drop to about 55. And we're making about 9 gallons an hour. And let's turn B back on, A off, and the exact same thing. We're about 55 psi, about 9 gallons an hour. I measured with a clamp meter. They're drawing 8 or 9 amps each, so right within spec. Also notice how quiet this system is. I mean, you could easily carry on a conversation right here, and it's fine. And these systems are usually in a locker or down below deck, so very quiet. So also with this system, you get 50 feet of reinforced 5/8 hose, charcoal filter, 5 micron filter, your filter wrenches, 3-way valve, some SC1, a TDS meter that I was just using, a manual, and then of course the service kit and the install kit, which is mostly in use on my test bench here. So that's about it. This system is working great, and now I will shut it down and give it a good freshwater flushing and pickle it with SC1. Thank you very much.